In fact, this is my first visit to India. I already knew many Hindi words before, so it's now time for me actually to practice this in Mumbai. Well, I'm going to talk actually about our experience in research, and this is innovation and research session using the HPC. And I'm coming from Jeddah. Jeddah is a coastal city like Bombay, and we are in King Abdulaziz University. So we are in fact in the Center of Excellence for Climate Change research which deal with weather and climate in terms of prediction and also climate research studies. And just to give you a brief about the climate system, in fact, is heterogeneous. It's not just only monsoon, sea and land, but it has a lot of interaction with the atmosphere, with lakes, with the clouds, with the sun. So it's really too complex to solve, in fact. And in the past, actually, the people used to solve only in terms of atmosphere and ocean. But with the development of science and advancement, we were able to include many other parameters. And we are currently, we are in like an air system where all the sea ice, ocean, aerosols, boundary layers, snow are all connected to other, and we are able now to resolve many aspects of the climate complexity. And in terms of research, in climate research, there is a lot of simulations nowadays, as you know, simulating the extremes, early warning system, pre-monsoon issues, and also to solve in terms of spatial resolution and temporal resolution of weather and climate models, in fact. This is also, we do some of the simulations that we do, not just only one run, but we do different runs, and these are runs, we take the average of them, which we call them ensemble members of the prediction. As you know, these type of things always requires to have high capacity of storage as well as high number of processors for running these type of models. And even as you can see, the IPCC report, whereas the report is related to climate change, has evolution to increase its resolution from 500 kilometer to 250 to 180, and then we go even up to 100 kilometer, and also we go up to 50 kilometers, and some of the simulations for regional modeling we go up to 25 kilometer resolutions. And in fact, these are all has to run in high computing facilities for simulating this Earth and atmosphere in general, in fact. Now in King Abdulaziz University, it's an example of, as David was saying, about the customer that is dealing with this type of technology and the state-of-the-art machines. We just give you an example of what we are doing, and why we are doing this, in fact. And as you know, Saudi Arabia is in a desert, so it is hot in summer and cold in winter, and rarely we have some rainfall. And therefore, why we grow, we grow only palm trees because they are resistant to droughts. But what happened in the past is really drought gets so prolonged, and there was no floods, no flash floods, that normally comes in winter. And we had episode of about 7 years of dryness. And this one was able to destroy all our palm trees and some of the springs. Instead of having normal rains, recently, in Jeddah, for example, we had some extreme rainfall event. Although they are rare, but we had faced a lot of such extreme event. For example, the first one that we had, and recently, was really in Jeddah. In Jeddah 2009, we had the first extreme event where rainfall reached for Jeddah in one day 74 millimeter, where normally the rainfall in the whole month average is about 20 millimeter or even less. 120 people died here. And in the next season, in 2011, we had another extreme event where it has been recorded as 110 millimeter in 4 hours. Almost 11 people died, so we had some preparation. Here we were not prepared. Totally, we were not prepared. And even the warning system was not as good as it should be. And forecasting was not, it's just normal. I mean, it's going to be raining tomorrow, but it was expected to be normal rain. And then we had in other places, in the north, in Riyadh, for example, in the south. And you can see the cases that we are having now is getting more extreme than normal. Although it is drought, etc., but it's more extreme. So this is very fundamental issues of climate and climate change, not just only in Saudi Arabia, in fact, but everywhere in the world. And also we got some fantastic events. These are not cloud, this is just only dust. But it might reach up to 5 kilometers, it could reach up to 10 kilometers in the atmosphere. And therefore, we established the Center of Excellence in 2009 based on the requirement and the needs of the country. So KU, King Abdulaziz University, has initiated to establish this center for doing the research. And we have, as you can see, a lot of research activities, but we focus in database. And today we talk about big data, and we'll show you some example how the big data is important for research. There is a vision and leading center, but we are developing the state-of-the-art technologies for weather and climate, and also to establish, the ensemble prediction, which is the most important now, and all the Met offices like IMD, they're doing this at the moment, and to simulate the present and future climates. So this is just only some of the aspects of research that we are doing in CCR. And we have, in fact, more than the number of researchers are more than 20 people in terms of researchers, in terms of postdoc, in terms of PhD students, some of them from Bangladesh, some of them from Pakistan, some of them from the Gulf countries, and some from the Arab countries, in fact. And our evolution, in fact, of computing, and this is really very interesting thing. All what you need, you cannot just go to that big. You have to start from bottom to top. So the first start actually we had in the Department of Meteorology in KU in the university was really in 2007. And our start is about using just only a BC. So the first thing that we worked on was using a smaller regional climate model, which we ran the first time Linux machine. So we were at that time really zero level of research activity in terms of doing the simulations. So all our base was statistics using Excel, and we are very strong that time using SPSS, but to use the gridded data, to use high spatial resolutions, then you need really to simulate. So the first thing that we worked was really on a PC. And that time there are only one person. It was me, in fact. So we started to work on BC and get some training in some regional model. Then we tried to establish the center, and the first machine that we get was in 2009 was like a server with 32 cores. And that time we have about 5 people, and we were able to share the resources of this machine. So we give a user, and everybody had just a bit, please, and we fought a bit. And then we were lucky to have the first HPC machine. So you can see the evolution. And that time, almost 2009 or 2010, we get like 232 cores. And the storage, in fact, was 100 terabytes. And when we put this machine in the IT department, in the IT center of the KU, where all the computing facilities were there, the dean of that IT told me, look, Mansour, you have 100 terabytes. And that time said, you have the biggest terabytes in KU. Even our IT center doesn't have this storage. But we emphasize that we need this 100 terabyte. And our aims at that time was really on a regional scale. But when we get more researchers to come, when we get more students, we were fighting each other really to utilize this. So we distributed the nodes, we give people 16 cores, and we give this one 8 cores, then we give someone 32, 64. So we tried to make a balance between the research. So we were fighting. And as you can see, there was a need to have a bigger size of the HPC. And that was actually coming later on with the Aziz supercomputer, which is an HPC. And we have a story for that on how we developed with Fujitsu on finding this big machine now, which is 12,000 cores. And storage of it, you can see is, I don't know what is it. We can have a storage, but the storage of it is actually 7.5 petabyte. So it's really big jump from 100 terabyte to 7.5 petabyte. However, because we have limited storage here in this HPC, we bought different special devices, independent devices of data storages. So our center itself has grown its storage system, even now is up to 1 petabyte, just only this is storages of our modeling run. But currently, we are working on Aziz, and our utilization of this Aziz is about 30 to 50%. As you can see, climate modeling, weather modeling is taking a lot of the capacity of the system to run their models and their simulations. Anyhow, everything now is going forward with this HPC. We are almost completed 1 year of the contract with Fujitsu, but we will look forward to continue this in the future. Now, this just only to show you the example of type of models that we use. We have people like around 20 to 25. We expect that to grow to 30 in the coming 2 years. But you can see there is a variety of models that we are running at the moment and utilizing the resources of Aziz. I would like actually here just only to put some of the comparison between our old HPC, which is just only 230 core, as well as with the Aziz supercomputer, and how Aziz supercomputer is really advancing the research in KU and particularly to the climate modeling. And this is also can be an example for other type of research that can be done in the world. Now I'll just give you the example here. We have an handicast example. It is mean forecasting. We want to do forecasting, climate forecast for 35 years. And we need to do 12 months from January to December. But in sample, remember, it means that you need to run the model for each month 30 times, and then you take the average. So the total runs with the four experiment, you need 50,400 runs. And if you want to utilize our old system, the 232, then we need to wait 394 days to complete our simulations. See, it's really very big. But using the Aziz supercomputer, the HPC supercomputer that we're having, and utilizing 3,000 cores, then you will have finished, your job will be finished in 4 days. And if we utilize 6,000 cores, and that we can do, in fact, we can finish our run, our simulations in 2 days. It means that you are submitting at the same time 100 runs. Yeah, you can say, for example, 1,000 runs at the same time, you can do it, and then you can get the results in a very short time and short period. Adding to that, we are not able before to run it on our old CPU, old machine, because the storage that will be generated from this run will be like 2.4 petabytes, and that time we only have 100. So it's really, we are not able to hold this capacity of data, which is the big data that is really now hindering our research, is really the data generated. It's now not just only the computing. Pierre has already shown how is the advancement in computing facilities, night landing, whatever, is really huge, talking about. But the big problem that we are facing in research is the generated data that we have. I mean, 2.4 petabyte just only for 300 kilometer resolution. If you go to a very fine resolution, it's mean more and more. Now, the HPC, in fact, that I'm showing here is just only, this is for the center, in fact. And this is how we are looking, I mean, how is our work is going to be advanced in terms of having more national collaboration, having more international collaboration, more simulations that we can do. And this will help in even solving our own problems of extremes, climate change, all these future scenarios. And this is just only an example of the CCR, which is the climate part. And KU, in fact, is not just only a climate center, but there are many research centers in KU, medical, engineering, physics, chemistry. And our aim in purchasing this HBC is also to take the lead for other centers to utilize this type of research activity. Thank you very much.